All right, good evening, and thank you for joining, and congratulations on your success in your Unit 1 chemistry. I had the Unit 1 chemistry seminar earlier, and I had to tell the students that by far the Unit 1 chemistry syllabus is one of the most difficult syllabi to complete. And if you complete and you do very well in Unit 1 chemistry, it is a big statement about you. So congratulations. So for persons who are just meeting me, I am Miss Smith from Extra Time Tutoring. And I would love to tell you about what to expect in Unit 2 chemistry. I know that, at this level, the persons who are here are trying to achieve excellence and mastering it. It's not so much because once you have been successful in Unit 1 chemistry, it's almost guaranteed that you are going to pass Unit 2 chemistry. But I know that it's not just about you having a pass in the subject. You are trying to master the subject. And so I want to give you that overview of what to expect in Unit 2 chemistry for you to master it. And even though its syllabus is not as long and as difficult to finish as Unit 1 chemistry, it is still fairly long and it still has its levels of complexity because, again, at the CAPE level, we're going into granular detail. All right, so chemistry is a branch of science concerned with the properties and interactions of the substances of which matter is composed. The CAPE chemistry syllabus provides the specific knowledge base and skills and attitudes associated with the advanced study of the subject. It is structured to ensure that students become aware of their moral, social, and ethical responsibilities, as well as the benefits to be derived from the practical application of scientific knowledge. Completion of the course of study outlined in the syllabus will enable persons to apply chemical principles to societal concerns such as birth control, communicable diseases, environmental pollution, global warming, and the depletion of natural resources. So again, CAPE is expanding your horizons for you not to just see chemistry as something confined to the lab and equations. They're showing you that it is empowering you to implement or to actually practice your moral, social, and ethical responsibility. And chemistry is required for knowledge and designs of birth control, control of communicable diseases, tackling environmental pollution, global warming, etc. So you're seeing chemistry at a larger scale. So let me show you this video about ways in which chemistry is used to enhance the environment, enhance industries.
The world is currently facing some major challenges: protecting the environment, developing sustainable energy, maintaining public health, and securing food and water supplies. Chemistry is the central science, the science concerned with all physical matter. We need creative chemists to find solutions.
Take climate change, the biggest challenge to human and ecological survival. Chemists strive to gain the knowledge needed to protect our planet. They observe the subtle changes in the environment, like ocean acidification, atmospheric pollution, and the buildup of marine plastics. Chemists at the University of Plymouth are at the forefront of research in this area, informing policymakers on how to protect our futures. They are not just in the lab, they are found working in extreme environments across the Earth, from the tropics to the remote deep oceans and the frozen polar regions. We know that sustainable supplies of energy are needed to replace our reliance on fossil fuels. Chemists at Plymouth create chemical models to innovate industrial processes. They work with nuclear reactors and develop catalysts that can recycle waste into new materials and energy. Chemists collaborate with industry to help businesses improve their operations on a local and global scale.
At Plymouth, I'm working with a team that care about these issues. I'm learning the hands-on techniques that industry and employers seek. I want a degree and a career that support change. I believe that together we are the innovators of the future. Find out more about our courses and the students and staff that have made a difference.
So guys, this video was to show you in action where, if you are going to pursue chemistry, where you will be several years from now. You are one of the chemists that are providing solutions for environmental problems like ocean acidification, environmental pollution. Chemistry is required for that. And you see in the video, one of the chemists was collaborating with an industry to give them solutions. So I want you to see chemistry on that broader scale and realize that that's what you're being prepared for. You're not just being prepared for an exam. You're being prepared as a scientist who can offer solutions for the very problems we have and to contribute to the development of a sustainable future. All right. So that's why you're learning this. Now, there are 3 modules. 1, 2, and 3. Module 1 is the chemistry of the carbon compounds. By far, module 1 is the longest of the 3 modules because you go into so much detail. You learn about so many families and you have to learn the reactions for each family. And at this level, you not only learn the reaction, you have to learn the mechanism. And this is the first time that you're going to be introduced to mechanism in chemistry. And this is something you're going to continue doing in university if you go study at the university level. And basically, you're not only required to know the chemical equation, you have to know the steps that took place. And you're now going to learn that the chemical equation is actually just the final summary. You don't have to present the steps. You're also going to learn analytical methods and separation techniques. And this is definitely preparing you for higher level chemistry because a lot of these techniques you're going to have to see at the university. We don't have them in your labs at school, but it shows you how to use different machines to analyze different properties, such as the concentration of substances or to identify various substances in a sample. And then we look at industry and the environment, how our knowledge of chemistry allows us to design very proficient industries and how those industries impact our environment. So for module 1, for the chemistry of carbon, we want to appreciate the scope and nature of carbon-based compounds, understand the processes involved in the formation of carbon compounds, understand the reactions of various functional groups of carbon compounds, and critically assess the impact of carbon-based compounds on our daily lives. Now, even though it looks short because it looks like it only has 4 topics, especially topic number 2, very long. So we're going to first go into organic chemistry, learning the structure and formula for organic compounds, learning what are some special properties of carbon that allows it to form so many millions of organic compounds. And we'll learn about structural isomers or isomers. We're going to learn about geometric isomers. We're going to learn about empirical formulae and molecular formulae. So that will be your introduction. And then we get into looking at the various functional groups, their reactions, and the mechanisms. So this would be the longest part of module 1 because we have to learn about the families. We have to learn about alkanes and alkenes and alcohols and carboxylic acids, esters, aldehydes, ketones, benzene, and the derivatives. So there are some families that you're going to get introduced in CAPE that you never saw in CXC. Then we're also going to learn about acidic and basic organic compounds, like what affects the strength of acidity in organic compounds and what affects the strength of basicity. And we're also going to learn about polymers. So unfortunately, this video is unavailable for structure and formula, so let me move on. So functional group analysis, I want to show you this video about one of the things you're going to learn, which is an SN2 reaction mechanism for how aldehydes and ketones react. But I'm just showing you, knowing that you're not going to understand it just yet, but it's just to give you a preview of how deep we're going to go into the organic chemistry. So this is showing you the way hydroxide ions attack an aldehyde, and you have to be able to say what happens first, what happens second, what happens third. This is what we call a mechanism, where it's showing you step by step how a reaction proceeds. That's the level that we're going to be at in CAPE Unit 2 chemistry. We're also going to learn about polymers. And here's a video I have on polymers.
Interfacial polymerization is a unique type of step growth polymerization in which polymer is formed at the interface of 2 immiscible phases. In this example, hexamethylene diamine is dissolved in water and makes up the bottom layer. The top layer is composed of sebaceal chloride dissolved in hexanes. At the interface of the 2 phases, monomers react, forming the polymer nylon 610. By carefully removing the nylon from the interface, polymer will continuously form until either monomer is depleted. Interfacial polymerization is a unique type of step growth polymerization as it allows for the formation of high molecular weight polymers without the need for equal molar amounts of each monomer. It can also be performed at ambient conditions. Thanks for watching.
So once we're done with module 1, we go on to analytical methods and separation techniques. And this module is designed for us to appreciate that all measurements have some degree of uncertainty. So we're going to understand that there's no perfect measurement we can make, that we are going to make errors in our measurement. And the greatest thing is to minimize the error, but errors will be made. We're going to understand the basic theoretical principles, demonstrate a knowledge of the basic equipment and operational procedures, as well as carry out experiments associated with selected methods of analysis and separation procedures. We're going to learn how to use experimental data to quantify substances or elucidate structure. And we're going to learn how to demonstrate an awareness of the wide applications of various methods of analysis and separation techniques in industry and in medicine by citing examples. All right, so this module 2 has several subtopics here. We are going to learn about the errors associated with our measurements and how to minimize it. Then we're going to learn about titrometric volume, which is volumetric methods of analysis, which is titration. Gravimetric methods of analysis. Gravimetric is new to you. Titrations you would have met. Gravimetry is new. Then spectroscopy is also new. So this is new. And this is something you will see at the university. I believe the University of West Indies usually has like a college fair, not a college fair, a scientific fair. And high school students are invited so you can see this machine. You're going to learn about ultraviolet and visible spectroscopy. And spectroscopy is basically using light to analyze the concentration of substances in a solution. And we're going to also learn infrared spectroscopy, where we use infrared radiation to analyze the concentration of substances in a solution. Mass spectrometry, which is where we try to break up compounds into fragments so we can understand the structure of the compound. And then we have chromatographic methods of separation, where we separate substances based on the speed at which the components move through like a stationary phase. So we're going to learn several methods of chromatography, and then there's phase separation. This one is usually one of the more challenging topics in module 2 and in unit 2 chemistry, phase separation, because it's such a unique concept to us. It's because when we learned about mixtures and separations in CXC, we learned how to separate mixtures when they were in 2 different states of matter, usually, or if they were not in 2 different states of matter, they had big differences. So like you learned how to separate like solids from liquids, or you would separate 2 solids, but one was soluble in water and one was insoluble. But there were big differences between the substances that you were separating. But here it is, in phase separations, you're going to learn how to separate things which are very similar. You're going to learn how to separate substances which have the same solubility. Their boiling points are very similar. They have similar polarities. So it's very difficult to separate them using the traditional mixtures and separations. So now you're going to learn about fractional distillation, you're going to learn about vacuum distillation, and you're going to learn about solvent extraction. So these techniques are so new to you, and they also involve calculation. So the only calculation in module 2, sorry, in unit 2 would be in organic chemistry for the first topic, and this topic number 9. Not much calculations. So I have some clips to show you some of these topics that you're going to learn in module 2. So this was basically to kind of give you an idea of how gravimetric analysis is done. And it's that you're really trying to find out the concentration of a substance, but you're trying to get it out as a solid precipitate, and then you weigh that precipitate. And then you do your calculations to work your way back to see how much was in the solution. So that's gravimetric analysis. And then the spectroscopy, UV visible spectroscopy, is based on shining light on a substance, on a sample. And you really want to see what percentage of the light went through the sample and what percentage was absorbed. And that is able to allow you to calculate what was the concentration of the substance in the container. Then you have chromatography. I want to show you this video on the application of the knowledge of chromatographic techniques.
The Secret Service is more than black sunglasses, earpieces, and two-piece suits.
They're also an elite team of investigators solving some of the nation's biggest crimes.
Sometimes using nothing more than a blot of ink. Here we are, the lobby of the Secret Service.
These were the only authorized shots we could get.
Upstairs in the lab, we got to see all the high-tech machines analysts use in forensic investigations. They have names with things like 8,000 after them, so you know they're complicated.
Did you film a printer?
I did.
The lab includes people like Trista, who specializes in handwriting analysis to investigate threat letters or ransom notes. Jeffrey investigates fraudulent items, like IDs, traveler's checks, credit cards.
And Irina, she works in the International Ink Library.
My name is Irina Gaiman. I am a document analyst with the United States Secret Service. The Secret Service has the largest ink library in the world. There are over 12,000 inks that are currently in a collection.
This includes pens, bottled ink, and printer cartridges.
Basically, this team of scientists is using ink to help solve crimes.
They're ink investigators.
No. Don't do that.
Okay, so here's an example. Someone writes a threatening letter to the president.
Irina will sample that ink and then compare it to her collection.
Exactly. She can figure out what kind of ink was used, and hopefully it helps solve the case. Here's another ink example.
No, give me that script.
The most counterfeited banknote within the United States is $20, and it's printed with inkjet, which means somebody takes their very simple at-home printer and decides to print money.
Irina can compare the counterfeit currency to any printers found at the scene of the crime and help make a match.
Okay, time for a little science.
Here's why you need 12,000 samples of, let's be honest, mostly black ink.
A lot of the black inks are not just black. They're actually a collection of different color components that could be blues and reds and yellows, maybe a little bit of green.
Irina can, for lack of a better term, sequence black ink like you would DNA and find the exact breakdown of color.
That's how she can make a match.
So what appears black at a first glance is actually extremely different on the inside. And it's really fun as a chemist to be able to take the ink apart and see how it's made. I'm a nerd at heart. I love the chemistry of it. I love the mystery of solving a case. I just really love what I do. So it may not look exactly like it's on TV, but it's really fun to be in a lab and to be able to do the analysis and to be able to help and assist all the law enforcement agencies that I work with daily.
So Irina, can you give us any more examples?
It's on a need-to-know basis, and you do not need to know.
Well, it looks like this case is all dried up.
All right, guys. So this was to show you how the knowledge of chromatography is used in solving crimes, right? So I don't want you to ever think that you're just learning these things in a vacuum. These things are applicable. So the final module, module 3, wants you to appreciate the chemical principles that can be applied to industry, understand the sources of pollution and strategies which assist in reduction of pollutants, understand that there are physical and chemical changes occurring in the environment and assess their impact on it, recognize the influence of industrial processes on social and economic life, and appreciate the impact of man's activities on the environment. So we have 10 topics in this module, but the topics are not very long. So first we learn about what are the factors which determine where we put an industrial plant, benefits and risk. And then we learn about the aluminum industry. We learn how to extract aluminum from its ore and what are the impacts on the environment. Then we learn about the crude oil industry, how to extract and purify crude oil and how it impacts the environment. We learn about the ammonia Haber process, how we manufacture ammonia, and how it impacts the environment and its uses. We do the same for ethanol. How we get pure samples of ethanol by fermentation or the hydration of ethene, its uses, and how it impacts the environment. Same for chlorine. We learn about the various cells: the diaphragm cell, the chloralkali cell, the diaphragm cell, the mercury cell, and the ion exchange cell. So we learn about how to manufacture protein, the uses of protein, and the impact. Same thing for sulfuric acid. Then we also now learn about water pollution and what are the pollutants for water, the water cycle. And we also learn how to purify water for drinking purposes. We also learn about the atmosphere, what is the composition of the atmosphere, and we learn about pollutants in the atmosphere, such as ozone. Ozone can be a pollutant if it's in the stratosphere, in the troposphere. We learn about global warming. We learn about CFCs. We learn about acid rain. So we learn about atmospheric pollution. And then we also learn about solid waste management, which is how to dispose of our garbage in an environmentally sustainable way. So here are a few videos I want to show you, like, for example, on the aluminum industry. Oh, well, I don't think this was a video, unfortunately. Sorry. It was showing you molten aluminum being formed. All right. This is showing you how to get fresh water from seawater by desalination. And countries such as Singapore and other countries that do not have any natural rivers and lakes have to resort to desalination. So they have to get the seawater purified by filtration. And then once the water is free from pollutants, then they have to remove the high concentration of salt, and they do that by reverse osmosis. So they're literally forcing water to move from an area of high concentration, well, low concentration to high concentration. So it's forcing the water to go against its gradient, and that requires energy. And we end up getting fresh water and from the salt water, and the salt is collected. So here's showing you that we force fresh water to come out of the seawater and leave the salt behind. And this is against the natural osmotic gradient. So it's called reverse osmosis. Then it's treated with chlorine to disinfect it, and then it can be used. Very expensive process, but it is a life-saving process for those countries that have limited fresh water. So starting from this week until the end of April, there are 32 weeks, and 6 weeks of which will be taken out because you have no school. December break, Heroes Weekend, Easter break. So that leaves us with 26 weeks. And usually 34 classes are at least, or 34 weeks minimum, are required to complete the CAPE Unit 2 chemistry syllabus. So there will be a few extra sessions that we have to add in order to complete it comfortably. Now, we look at the assessment. So you have, guys, you're going to have your paper 1 and your paper 2. So paper 1, of course, with your multiple choice questions, 15 questions from each module. In total, 45 questions, making up 40% of your final grade. And in section paper 2, you have 6 questions. 3 questions are structured questions, which test the application of experimental skills from each module, 15 marks each. And then section B now has 3 compulsory essay questions, 1 from each module. Each question is worth 15 marks. So with the 6 questions being weighted to give 40%. Now, in addition to that, you have your labs, which contribute 20% of your grade. So this is just telling you some more about paper 1 and paper 2, which we already discussed. And they don't have any specific number of labs that you have for Unit 2 chemistry, but you must do 2 labs on each of these skills: observation, recording, reporting, manipulation and measurement, analysis and interpretation, planning and designing. So therefore, it means that you must do at least 2 labs per skill. And they have to be from each module. So you have to have labs from module 1, 2, and 3. Because when you look at the overall marking, you'll see that the paper 1 multiple choice has 15 questions from each module, giving you a total weighting of 45, and that contributes 40% of your grade. Now, there are 2 sets of questions in paper 2. So we have structured questions, 1 from each module, and these are experimentally based questions with up to 45. Then the essay questions are 15 marks, 1 from each module, 45 marks. So the total for paper 2 comes back to 90 marks, and then it is scored down to 40% of the grade. So the labs now, internal assessment, you have to have points from each module as shown here. So that comes to 48, which is then weighted to 20, and that gives you the total grade. So you must make sure you have a minimum of 3 hours of preparation each week. And after each each class, you have to do the essay questions and multiple choice questions. Well, at Extra Time, that's a program that we use. So we would ensure that we found the questions that are relevant to the section you just learned. Having taught you how to do it, having seen you do an example, then the next thing now is to have you do the past papers and submit it to be marked. Use the CAPE mark scheme or the CXC mark scheme to mark it and grade it so you have an idea and you can calibrate how well you are performing and know how to improve, or if you're doing very well, how to sustain it. And you try to score optimally in labs, which is to get at least 20%. Now, your final grade, which we are aiming for, grade 1, would mean that you have to show mastery for all 3 modules. Module 1, chemistry of the carbon compound, module 2, analytical methods and separation techniques, and module 3, industry and the environment. Make sure that you have your own personal copy of the syllabus. Tick off the objectives that are covered each week. Read ahead on the experiments that are to be done for that objective. Watch those experiments on YouTube so you get a visual insight into the topics and into the lab before you do them. So the challenges that I find with Unit 2 chemistry is that the module 1 is very long. So when I start, and I was reading the examiner's report for the Unit 2 chemistry, and it was saying that the organic chemistry tends to be like one of the weakest areas for the students in Unit 2. Module 1 is very long, which is organic chemistry, because when we start it in September, we're starting classes next week, Saturday. Once we start the classes, it usually goes all the way down to December for us to complete all of those topics, all of those subtopics in module 1. So if that's taking us all the way down to December, then we start in January with the new module 2. That takes us a couple of weeks very well. So then that leaves us with a limited time to do module 3. But because module 3 is so descriptive, because literally it's just learning about each industry and its impact. So it's literally just reading it through. It allows us to do the module 3 more quickly. But the module 1, there's no way to rush it. You have to see those mechanisms and you have to practice it. So that's usually a challenge. And then I find that you students, you struggle with remembering the mechanisms, especially if you don't practice it. So if I showed you a reaction of alkenes with halogens, and I showed you the mechanism, and you never went and practiced it, you're going to forget that. And by the time we go through 8 families, and each family has 3-4 mechanisms, you're looking at 25-30 mechanisms that you need to remember. And if you weren't doing them one at a time and finding a way to remember, then you're going to struggle at the end with all these mechanisms to remember. So organic chemistry has that challenge. Module 2, this one is not so much a calculation for module 2. Module 2 now has it does have complex calculations. Not all the topics have complex calculations, but you're looking at calculations in titration analysis. You have calculations in gravimetric analysis. You have some calculations in UV visible spectroscopy. You have calculations in phase separation. So at least 4 of the topics in module 2 are heavily calculation based and they are complex. Those must be practiced as well. So module 1 and 2 definitely will be your more challenging modules. Module 3 now is more descriptive. So that one you can read and sort that. But module 1 and 2 definitely have to learn. So I got this from the subject report. It says that candidates continue to perform poorly in paper 2. This performance and some modules demonstrate that they did not have the expected knowledge, skills, and abilities. Some candidates had challenges answering questions in which they had to apply, analyze, or synthesize information. Several candidates demonstrated limited experimental knowledge and skills on questions which required them to demonstrate their practical knowledge and experience. So this is the general feedback that they had about the Unit 2 chemistry. So I just wanted to share that with you from the subject report. So guys, I believe though, if you were able to achieve discipline in Unit 1 chemistry and were able to perform well, Unit 2 chemistry is not as difficult as Unit 1. It still requires a lot of discipline and focus, but it's not as tedious as Unit 1, but it still requires you to work consistently each week. So make sure that you apply yourselves and keep on top of things. Make sure that you look at the objectives in your syllabus to see if CAPE has given you a suggested practical activity for that objective, because it means that even if you do not do a lab, because CAPE has given you a suggested practical activity, they are free to test you on it in the exam. Once they give you a suggested lab, you're expecting that you're either going to do the lab or you're going to research it, but you should know it. It's a part of what you should know for the exam. So guys, that's where we're going to stop today. Do you have any questions? All right, so thank you so much for attending. All the very best in your studies, right? All the very best in your journey for Unit 2 chemistry, and have a wonderful evening.